Alright guys, welcome back. It's been a while since we've watched videos. Quick shout out to Isaac, Shannon, Sarah, and Parker. This one we're going to be doing, we kind of have to remember back to when we were doing our 30, 60, 90, 45 angles, and you have to remember what cosine and sine and tangent were at those places so we can actually figure out other trig values, such as cosine of 15. Cosine of 15 is not on the unit circle. However, there are identities that help us break 15 into two different numbers that are familiar to us. So, real quick, I'm just going to put this up on the screen. You will get these in class. I'll probably pass these out during class so you guys could have them. But if you want to take a quick look, these are the identities we're going to be using. Basically, it's saying if we have two angles subtracted, then it's cosine of one, cosine of the other, plus sine and sine, and so on and so forth. So, just you can pause the screen and write those down if you want, or you can just go along with the notes as we're going. So, first things first, we have the cosine of 15. So what you have to decide is, how can I get 15 using our numbers? And when I say our numbers that are we like the numbers of 0, 30, 45, and 60. And I guess 90 works too, and 120 and all that stuff. Because all these angles, we know what we should know, keyword is should, know what cosine and sine are at those values because of our unit circle. So, what's one way to get 15? Well, I think the easiest way to get it is to turn 15 into 45 degrees minus 30 degrees. Those are both angles that we can use. So this is going to be like my x and my y. Okay? So if you guys remember from looking at that other sheet, I'm using subtraction here. So the subtraction formula for cosine is cosine of x, cosine of y, plus sine x, sine y. So I'm going to plug in my values. Cosine of 45, cosine of 30, plus sine of 45, and sine of 30. Now, this is where you have to remember your angle, or your values. First off, 45 degrees, we're in quadrant 1, and we get root 2 over 2 for both of them. I don't know what this is yet. But we should know that sine and cosine at 45 are both root 2 over 2. Hopefully you're familiar with that. The other two are 1/2 and root 3 over 2. So we have to now figure out at a 30-degree angle. I'm just going to quickly sketch a 30-degree angle here. Which one's which? Well, if you look at it, the 30, the y is very short, the x is long. So that means the y would be the 1/2, the x or the cosine is root 3 over 2. Okay, that's just using my unit circle information. So my sine is 1/2, my cosine is root 3 over 2. I multiply and I get root 6 over 4 plus root 2 over 4. And since they have a common denominator, we can at least put them together on top. No, you cannot add a root 6 and a root 2 together though. So this is the most simplified form. So the exact value of cosine of 15 is that. Okay, root 6 plus root 2 over 4. And we did that using our sum and difference, well, in this case, a difference identity. Okay. Alright, so let's find out what 75 is. 75, sine of 75. This is one that we have to break down. We have to use 30s and 45s. Oh, well, isn't 30 plus 45 75? Yes, it is. So we can use the sine formula on the first page. And I'll just write it out for you guys real quick. Sine x cosine y plus cosine x sine y. Okay? So, alright, let's see what we got going on here. So we have sine of 30, cosine of 45, plus cosine of 30, sine of 45. Alright, well, we already did sine and cosine of 30 and sine and cosine of 45. It's pretty much the same thing. Sine of 30 was 1/2. This was root 2 over 2 for the 45s. This was root 3 over 2. You guys, again, should just know these, and if you don't, I would recommend looking back in your Trig Chapter 1 packets to that chart we made on the day of our unit circle. And when you multiply out, you get the same thing. You get root 2 and root 6 over 4, because you get a root 2 over 4 and a root 6 over 4, and so you get root 2 plus root 6 over 4, which makes sense because, think about it, 75 degrees is 15 degrees away from the 90, and 15 degrees is 15 degrees away from the 0. So they should be the same thing. Sine of one of them should be the cosine of the other. It's like how sine of 30 and cosine of 60 are the same. So this one's the tricky one for a couple reasons. One, we're dealing with tangents. Okay. Now, to refresh your memory, at 30 degrees, tangent is root 3 over 3, and at 60 degree angles, tangent is root 3. And that's, you get that from dividing sines and cosines, but I don't want to spend time doing that again. At 90 degrees, which we don't want to deal with, we pretty much want to deal with these. Oh, 45 though, it's either 1 or negative 1. So 45 tangent's 1. 90 degrees is y over x. It's undefined, so we don't care about that one. Alright, so tangent of 11 pi over 12. Well, think about breaking down 11 into two values. Again, just think about breaking down a fraction. 2 and 9. Well, if you do 2 over 12, you get pi over 6, and 9 over 12 is 3 pi over 4. So that could work. We can also do a 3 and an 8, so that's pi over 4 and 2 pi over 3. So either way you do this, it will work out. I'm going to say that this is 3 pi over 12 plus 8 pi over 12. And if I simplify those fractions, I have angles that I really like. Pi over 4, which is a 45 degree angle, and when you divide these by 4, you get 2 pi over 3. Just so you guys know, this is like 45, and pi over 3 is 60, so this is 120. Okay, all right. Just for our help thinking about these. Now that is important because you have to remember what quadrant we're in for tangent. All right, so going back to the sheet real quick, tangent is this kind of crazy formula. Again, you will get these on the test, and so I did an adding one. So it's tan x. So it's tan x plus tangent of y over 1 minus tangent x tangent of y. And there it is. There is my formula I'm going to use to figure out this value. Okay? Now, a pi over 4 is a 45 degree. So again, this is 1. Plus. Now be careful here. When you're in the second quadrant for this one, that's over here, tangent is x over y, or y over x. Well, y is positive, x is negative. So this value should be negative right now. So we have 1 plus a negative, and since it's a 60 degree reference angle, that would be your root 3. So it's really 1 minus root 3 on top. 1 minus, and then this becomes 1 times negative root 3. So we get 1 minus root 3 over 1 plus root 3. However, we don't like radicals on the bottom. We've talked about this before. You guys have had practice with this already. What do I multiply by? The conjugate, because that gets rid of our radical on the bottom. So 1 plus root 3 is we multiply by 1 minus root 3 on top and bottom. FOIL both things out. I'm going to scroll down a bit. And then you get, on top you get 1 minus 2 root 3 plus 3 all over 1 minus 3. So when you simplify that, you get 4 minus 2 root 3 over negative 2. Factor out or actually you can just split it into two fractions. I'm going to do that because some of you guys think that you can cancel at will. This is the same thing as 4 over negative 2 minus 2 root 3 over negative 2. And now we can cancel these out. 4 over negative 2 is just negative 2, and this becomes plus root 3. And there's my final answer for tangent. Okay? Alright, so the hardest thing is A, dealing with radians, B, dealing with tangent, just because you guys aren't as familiar with those values of root 3 and root 3 over 3. The reason why I chose the numbers I did, I wanted to do either a 60 or a 120 because that's just root 3. I don't have to then deal with fractions. So whenever possible, if you can break down tangent, you want to either get it into pi over 3s or 60-degree angles, so you don't have to deal with this fraction. Alright, now, number 4, assume that A and B are in standard position and cosine of A is root 2 over 2, sine A is less than 0. So this is kind of what we were doing before, except for we have two different angles here. So just do these problems independently of each other, first of all. So we have cosine of A is root 2 over 2. So that means positive root 2 over 2. Hopefully you guys realize that's like a 45 degree, even though it doesn't matter. We don't need the actual angle. If cosine of A is root 2 over 2, that's a unit circle angle. But sine is less than 1. So that's going to go down here. So this is A. I know because I gave you a unit circle number that this is negative root 2 over 2. This is root 2 over, oh, nope, that's the hypotenuse. This is root 2 over 2 for the x, because it tells you that. And this is 1. Okay? That's our unit circle angle. However, we don't always get unit circle angles. For example, this one over here tells me tangent's positive, so that's either 1 or 3. And then sine is positive, so it has to be 1. So this angle is over here. Okay? And this is angle B. It's a full different triangle. So, you know, there it is. And I know that at B, tangent is opposite over adjacent, so this is 12 over 5. This is not a unit circle angle. So we have to find the third side like we used to. We have to find this side using Pythagorean theorem. Hopefully you guys know that 5 squared plus 12 squared equals x squared. And then when you solve that, you should get x is 13. You should remember your triples, hopefully. So this is 13. Alright, so now I have set up my two triangles. Again, we did this in chapter 1. I just put them together. Now it says find cosine of A plus B. So I'm going to write out my identity that's on the sheet of paper. Cosine of A plus B is the same thing as saying cosine of A, cosine of B, minus sine of A, sine of B. Okay? And now this is actually really easy because we have all the angles. We look at them. Well, cosine of A, we already know, is root 2 over 2. If we go to the B triangle, cosine is adjacent over hypotenuse, which is 5 over 13. We have a minus sign. Sine of A is negative root 2 over 2. Don't forget the negative because it tells you sine of A is negative in the problem. And then sine of B, you look at our angle, opposite over hypotenuse is 12 over 13. So there's our setup. Multiply everything out. You get 5 root 2 over 26. And then this is a minus, so it becomes plus 12 root 2 over 26. We get 17 root 2 over 26. So the cosine of alpha plus beta is that. And all we did was use two triangles to do that separately. Okay? Last one, prove the following identity. All right. You guys should be wizards at this stuff now. Obviously we want to work on the left side because we now have a formula for these. I basically gave you what this is and what this is. So I'm going to just sub this in. Cosine of x minus y is cosine x cosine y plus sine x sine y plus this one here turns into cosine x cosine y minus sine x sine y. And we have to equal that to 2 cosine x cosine y. Okay. Hopefully you guys, all I did was expand these two things. Hopefully you see that this term here and this term here go away, and these two add together, so we get 2 cosine of x cosine y equals 2 cosine of x cosine y. And there was our identity for that one. Pretty simple. Alright, so that is it. Again, that was only 15 minutes. That's not too bad. You got to practice breaking down those fractions into angles you want to do and work on that in class. I will see you guys later.